Hi, and welcome to tonight's session. So we'll get started. It's 6:30 p.m. So hi, my name is Barbara. I'm a Sustainability Education Officer for Willoughby Council. And welcome to tonight's session that we are running in partnership with 4 other councils. So we have Ku-ring-gai, Lane Cove, Mosman, and North Sydney councils involved as well. Before getting started, I'd like to acknowledge that wherever we are today, we are all on the lands of Aboriginal traditional owners. And I'd like to pay my respects to the elders, both past, present, and emerging, and thank them for sharing with us their immense knowledge on how to care for this country. So tonight's session is the first of 4 webinars in our Introduction to Sustainable Building series that will be presented by experts from Renew. And tonight we'll focus on why and how to design for resilience when planning a new build or renovating your home. As councils, we're running these webinars to assist our community to reduce their greenhouse gas emissions. And we know that as residents, we all have a direct impact on the planet through our homes, and improving our built environment has a significant impact on how we can achieve sustainable living, reduce the energy that we use, but without compromising our comfort. So our speaker tonight is Nigel Bell. Nigel has been a practicing sustainable architect for 40 years with a Churchill Fellowship. He has received a number of awards such as the Blue Mountain Outstanding Environmental Business. He's represented the Australian Institute of Architects on the 3 bushfire Australian standards, as well as being the expert witness to the 2020 Royal Commission into Natural Disaster Arrangements. He also recently led the Renew Beyond Bal project, finding and presenting Australia's most bushfire resilient and sustainable homes. So with his wealth of experience, I will be pleased to hand you over to Nigel in just a moment. Before handing over, just a couple of points about the Zoom webinar. So the session will last about 90 minutes. Nigel will do a presentation for the first hour or so, and then we'll have about half an hour to answer some of your questions. If you aren't familiar with Zoom, so the chat function is at the bottom left-hand side of your screen. If you click on the icon saying chat, that will pop on the side and you can put some comments, general comments, or have a chat in that on that size. And if you would like to ask any questions to Nigel, we ask that you use the Q&A function so that we can see the questions and I'll be able to ask them to him after his presentation. So click on the Q&A, which is on the right-hand side at the bottom of your screen. And that will pop up. You can type in your question, press enter. You can also upvote questions by pressing the thumbs up. So if you see other questions that you wanted to ask, you don't have to ask the same one. You can just vote for other people's questions. If you have any issues, technical supports, please raise your hand. So that's the little hand icon at the bottom of your screen as well. And you can just click on that and someone will help you. Finally, we'll have a short feedback survey that will pop up when you leave the webinar, and we'd really appreciate if you can take just a couple of minutes to complete it. I'll also send a link via email if you don't have time tonight. Renew will send you a follow-up email with some links to resources of things that will be mentioned today. And finally, the webinar is being recorded. So we'll send a link to the recording probably about next week, and you can watch it again or share it, or yeah, we'll share it with other people. So without further ado, I will turn off my camera and hand over to Nigel.
Thank you, Barbara. Thank you for that introduction and welcome everybody. I'm speaking to you from the traditional lands of the Gundungurra and Darug people, which is Blue Mountains. And I'm happy to say that I've had a lot of experience basically through my career on having to be sustainable, having to design for resilience, because I live and work in the most bushfire prone area in New South Wales and possibly Australia. And of course, we're all suffering from increased floods and just landslip just 50 metres from where I am. And of course, depending where you are in the northern part of Sydney, around the perimeter, near the green gullies and so on, which is no doubt a very lovely place to live, unless there is a climate emergency, be it fire, be it flood, be it landslip. And of course, all of Sydney had the problem of smoke, even when the bushfires were inland from the coast or the major part of the city. So we're now living in an age of consequence, and sustainability resilience should actually be at the forefront. I'm happy to present on behalf of Renew because they are the leading organisation that is working at grassroots and community level to actually assist people understand what the issues are and how to deal with them. At the end, you'll see there is a number of references about gardens, about buildings, and a whole range of things that you might want to explore in your own time after this particular webinar. So Renew's been around for over 40 years. They have been running their Sustainable House Day, and next one is April the 21st. So if you go online and put in a Sustainable House Day, you can register, and they have typically 20 or more fascinating homes where you can actually do it online or in person and understand and talk to the people and actually see it for yourself. So this evening, in 45 minutes, we're going to talk about resilience and its importance, passive solar design, particularly important if you're looking at additions or a new home. But we'll then talk about retrofitting, because I'm sure most of you live in an existing house and you're probably trying to say, well, what can I do to make it more efficient, more comfortable, more resilient to fire or flood or smoke, whatever. So that leads into then case studies, where I'll show you 5 of my projects which combine some of these issues and how good design can actually address them fairly effectively. So, our homes and resilience. Sustainable, adaptable, scalable. I won't read it out, you can read it yourself. But the key point in that is that we need to be disaster resistant, because, as I'm sure you're well aware, in the last few years we had the mega fires of 2019, 2020, unprecedented. Since then, we've had repeat series of flooding examples, again, in many cases record and disastrous. Interestingly, the cost of repair from insurance companies for flood, storm and cyclone is many times greater than that it is for bushfire. But that's still very much a factor. And of course, being affordable is important to all of us. Sustainable, looking ahead, how we can minimize our environmental footprint and continue to live well with less, effectively, or with less consequence to the world. Locally appropriate, I believe, is very, very important. So I'll be showing you Blue Mountains examples because we, as I say, have some of the most extreme situations to deal with compared to the North Shore. But interestingly, most of my clients on these projects actually live in the North Shore or have moved from the North Shore. So I suggest it's relevant. Okay. Houses are normally our biggest financial asset. And obviously, people want to protect their property value, their property investment. Adaptable is increasingly important because we are obviously, populations shift. My children have moved out of home. Yours are, and perhaps you're living in a big home and yet you've got many bedrooms you're not using. So can we adapt our house? I've done a project for my daughter where we're able to divide 1/3 of the house off fairly easily, and she's got, as a woman with a young child, she's now got an asset which gives her weekly income from renting a secondary dwelling with no detriment to her lifestyle. So that sort of thing of being able to adapt is important. And then scalable, meaning that be it small or large, these are the principles we need to really try and incorporate in our everyday life. Again, I won't try and read all of that and explain it to you, but the key point is that we want our homes to be healthy and obviously comfortable. Healthy homes has become a mandate in the last 20 or 30 years, because obviously as we close our houses up more and more, particularly if we're into passive house concept, very closed up house, the off-gassing of furniture, of carpets, of paints are all become more important. 20 years ago, I'd use timber for everything because that was the sustainable thing to do. But now, of course, maintenance and the quality today of timbers is much reduced. So I'm using other more energy efficient and more resource efficient materials. You'll hear more later. Low embodied carbon. Now, you may or may not understand that, because what we're talking about is the carbon consequence of mining, of transport, of manufacture. Is it a high amount of energy in manufacture, such as cement, or is it low in energy, such as timber? So it is every material we use, what is the carbon consequence? Some, like timber, are the most natural, or earth, that's natural and minimal. By the time we get to aluminium, bronze, and many glasses, it's high. So we need to look carefully at where we use them. And then passive design elements, I'll talk that through. Obviously, ongoing everyday costs become increasingly important at a time of struggle for too many people, and resistance to extreme weather events of all kinds. So here's 101 on passive solar design. Passive solar has been around for tens of thousands of years, because if you lived in a cave or you lived in some kind of shelter, you would be looking at where's the sun path? Which direction does the cold winds come from? What about the rain? You would be organizing your life and your housing around those kind of principles. So we need to work with local climate if we're trying to minimize the impact of those kind of things on us. Obviously, human comfort, it's deemed to be between about 18 degrees Celsius and, depending which index, 25 or 27 degrees. So that's not a big range. Obviously, I put on a jacket before coming here because I'm in a colder climate than when you are. So we need to reduce the need for additional heating or cooling. So we'll talk about that. And of course, over the years, different terms are being used, but let's not worry about that here and now. We're talking about sustainability, which is one of the other overarching words, but increasingly resilience to adapt to change. So on screen, you can see the information which is purchasable as a book called Your Home, or entirely free online. So go into your web browser and put in Your Home, 6th edition, and you can get a wealth of short, sharp chapters with diagrams and photographs on all the topics we're talking on tonight and more. And the fact that the federal government 20 years ago paid for a very fine production, which has been updated fairly recently, it's definitely worth a look, because that's your best one resource to cover all the topics and more that we're talking about. There's some of the topics just there, which we're now going to have a deeper look into. Okay, so climate zones. I'm happy to tell you, you are in a wonderful temperate zone, which is zone 5 of the 8 that the government has determined for across Australia. And that's because you are near the coast. So hopefully on hot summer days, yes, it'll be hot, but you're going to get cooling sea breezes 10, 12, 15 kilometres inland. If you live at Penrith, for example, which is blue, pale blue on that, that's the next climate zone 6. And you may or may not remember that 3 years ago, during the bushfires, Penrith was the hottest place in the whole world for one day, 49.3 degrees. Penrith has extremes of heat and cool, as does many parts of Australia. I'm talking to you from climate zone 7, Blue Mountains, because at the bottom we're near Penrith, at the top We are in the dark blue, which is comparable to Canberra or Hobart and Tasmania. So frankly, in design terms, I live and work in one of the most difficult areas in that we have climate extremes, particularly at the cold end, and we have bushfire extremes at a place which is World Heritage. So bushfire versus environmental protection, key matter that I have to deal with all the time. So if different parts of Australia, you need different ways of addressing it. If you lived in Central Australia, what some of the earlier white settlers, colonialists did was have a very heavy brick core to a building, which would heat up or cool slowly, and then the veranda, the fly screen enclosure around, so that as the heat built up through the day, it'd be cooler in the middle of the house. But as the evening comes, it's got hotter and hotter in the middle, and they've got a cooling breeze. They would do everything to live, as did Indigenous people, under lightweight shelter that allowed the breeze to pass through. So get to know your climate, because if you are repurposing or renovating your house, these are some of the things you need to look at. Air temperature. Where is shade? Where does the sun path go? What about humidity? We've had some very high humidity in recent weeks or months. Solar radiation, breeze and rainfall. All of these are important everyday things that if you lived in a cave, you'd have to know everything about. But in our houses, unfortunately, it's too much is being forgotten. The key point of passive solar design is actually utilizing nature, because nature gives us a lot of what we need. And apart from the extremes, most of the everyday in a temperate climate works really, really well. That is, in summer, the sun in the middle of the day is high in the sky, 79 degrees in Sydney. But because of the tilt of the Earth and the path of the Earth and the sun, in winter, it's down to 30 degrees. So immediately look at that diagram and look at the eave overhang. So you can adjust an eave overhang or shading to keep out for 3 or 4 or 5 months, the hottest part of summer, but you can get it in winter when you want that free natural warmth. So the diagram on the right, and this relates to true north, is that in summer, you obviously want the sun coming in at the front, but you want to shade east, west, and south. In winter, it's far more important to be getting the sun coming into your home, particularly the rooms that you use mostly. So this diagram shows you the sun path relative to a 2-story house in summer, where it's up high, and winter, when it's down low at 30 degrees. And look at the shadowing. The shadow behind from the house and the trees, but look at the shadowing over the window shading, because you want to keep it out in summer, but you want it to come in through winter. Key point. And remember, east and west, it's harder to control the sun because it's low in the sky. And depending on trees, perhaps your neighboring house, hopefully they're giving you some shade. But if not, you need a different design strategy to shelter and shade east and west, because that has hours of morning sun before it moves around towards the north, and hours of extra hot late afternoon sun that you don't actually want coming into your home if you're trying to keep it at a comfortable, more even temperature. That's about heating. Now let's look at passive cooling. The point of that is to reduce the heat gain during the day through summer. You don't want, if it's 30, 35 degrees or more outside, you still want to be in that window of 18 to 25 or thereabouts. And if you can do it with passive cooling without turning on the air conditioning, you're well ahead. And that comes back down to clever solar design. So to reduce the heat gain, you look at the eave, you look at the amount of windows, and the type of windows, because some glass is better than others to reflect the heat away or absorb and re-radiate the heat away from your home, compared to what's been around for 100 years, just plain ordinary so-called annealed glass. So there's an increasing number of specialized glass that you select according to north, south, east, or west and what you're trying to achieve. I mean, any good designer understands this and will give you good guidance. So we're trying to increase heat loss if it's in summer. So ideally in passive house, you're opening up your windows or doors and you're trying to get the benefit of natural ventilation, quite apart from anything else. So cross ventilation, windows, doors. Now, if you have a small opening down low, for example, and a bigger opening the other side of the room, the other side of the house, or in my case, you may see above me, it's a Velux double glazed roof window. I open that up and it creates its own draft with no use of fans or electricity. But of course, fans are good. They only cost a couple of cents an hour to run compared to an air conditioner or anything else. So cross ventilation, doors, windows, allowing for that flow of air across, because our bodies respond and we feel 3 to 5 degrees cooler on a hot day if we have airflow over us. And of course, then it comes back to the type of clothing we're wearing and so on. So shading, I've already mentioned about shading away from hot summer, but allowing the sun to come in cooler months of the year. And of course, ultimately, you're reducing your energy costs, your energy bills significantly. If you have passive house cooling like this, passive solar, it's costing you nothing to run. It's just opening windows and doors because you've designed in an airflow. So to be highly recommended. So 2 more diagrams about orientation. And the one on the right makes a point that you usually want the living area where you are spending most of your day, you want that facing close to north. And the sleeping areas, presumably it's mostly dark when you're in it, then east or west or south. So you'll understand, depending where and how you live, particularly if you've got a very solid house, that if you get too much western afternoon sun, the heat bakes and comes inside. So this is the point of using wind, using shade, be it trees, be it neighbor, or be it in the construction of your house or your renovation or your addition, to actually encourage all of these natural systems to work positively for you. Cost no more. It's what every good designer understands and should absolutely put it into your project. And when it comes to shading, many ways of doing it. You can fix it by having an eave. But as I mentioned, east and west, wide eave isn't so useful because the sun is low in the sky and it comes in underneath. So therefore, you could perhaps use fence, external blinds, trellises, or again, vegetation, vines, shrubs, trees. So you can block the sun in summer, but allow it to come through in winter. In terms of vegetation, if you have deciduous vines or deciduous plants. So the point of that is you're trying to shade the wall and most particularly shade the glass of your windows or glass doors, because when the sun hits the windows or the glass itself, it's heating the glass and then re-radiating it in. So if you can stop the sun hitting the glass, you are many degrees ahead. Again, it's just sensible use of understanding these basic elements of passive solar design. Insulation, it's one of the cheapest quick fixes you can do, depending on what your house is built from. I live in a 110-year-old timber house, so it heats up quickly and loses heat quickly because there's no thermal mass to keep the warmth of the cool in. So I put in a double layer of insulation across my ceiling, And in my timber 4-inch walls, 105, 106 millimeter, we put holes into the timber, 50 millimeter, 2-inch, between every stud, and I pumped in polystyrene recycled cubes into the cavity. So I filled the cavity from the bottom up and then put the timber plug back in and finished it all off. So I have about R4 in the walls, and yet the insulation requirements across Sydney is R1.5. Similarly, I've got about R7 in my roof, but then I'm in a much colder climate than you are. But you should be looking at R4.5 or more if you can, and if you can afford it. R stands for resistance. The R value is the standard way we buy insulation and written into all the building code. So in New South Wales, everywhere you must have at least R1.5 now in the wall, and then you must have more in the roof or ceiling, just depending on the climate zone that you're in. So the higher the R value, the better. And if you go to Bunnings or Mitre 10, you'll see all the different bags of insulation, and on bold print, it'll tell you what the R rating is. So as the slide says, the priority is ceilings first because heat rises, walls because you've got a lot of wall, and then floor. And that's assuming that you've already done something pretty good with your windows. So insulation, you can never get enough of it. It's definitely worth spending some thousands to upgrade your existing home, even if you do very little else. It's one of the best quick fixes for human comfort. So in terms of passive solar homes, there are 3 ingredients: the type of glass, the thermal mass, and the insulation. So we've mentioned the first 2, but let's talk about thermal mass. Okay, I've mentioned I live in a timber house. It doesn't have thermal mass. I can't get thermal mass into it. That means my day-night temperature varies enormously, probably 5 degrees difference to the outside. And because of my insulation values, better than that. But if you have a really solid house, full brick, or on the image, that is an earth integrated or underground house built a decade or so ago, featured in Beyond Val. So when you have a lot of thermal mass, it slows down the temperature change, not just day to night, but week to week and month to month. Because an underground house like this one has probably half a meter of soil all the way across, as well as the concrete holding it up and the concrete blocks inside. So it's got the correct orientation. It's got the sun coming in through those arches and through those windows. And the architect, a very good one, put a secondary layer behind. So it's like having a veranda, a filled-in veranda. So we can open or close, depending on the temperature, to get the warmth right into the heart of the home behind, the kitchen, the living, the bedrooms, the bathroom. So it's a very good strategy in this instance, done well, to moderate the temperature. So in his instance, the temperature hardly varies, this is in Victoria, between 17 and 18 degrees for most of the year, with no extra heating, because he opens and closes windows and doors to maximize the gain, and the huge amount of thermal mass, what's called, holds it in, and the thermal lag could be 4 or 5 months. Whereas if you're in an everyday brick or brick veneer home, the thermal lag might be a few days, a week. If you're in a sandstone home, it might be longer. So again, how suitable this kind of thermal mass should be depends very much on the climate zone. And you guys are lucky. You are living in a very comfortable temperate zone. So strictly, you wouldn't have to go to that lengths in the Sydney region or certainly the seaboard region to do this sort of thing. If you're moving inland, moving up the north coast and inland, or moving closer to Central Australia, Okay, this is a concept that you might actually want to introduce and consider. So the last point was, why is it different to insulation? And the difference is the thermal mass holds the warmth or the cool for days or weeks or months. Insulation doesn't hold it, it just slows down the transfer day to night. So again, back to what kind of house you're living in, you probably need insulation as the foremost response. In temperate climates, having a thermal mass is less important than if you were building in the more inland or extreme climate parts of Australia. Glazing. Okay, so as I say, windows are increasingly important. 20 or 30 years ago, virtually every house had either timber and single glass or aluminium and single glass. In fact, half of the houses in Australia are totally energy inefficient because it's aluminium and single glass, 3, 4, 5 millimeters. So those are the ones that lose maximum heat loss in winter, and if the sun is shining on them, the maximum heat gain in summer. So look carefully, think about your house, think about the window orientation, and think about those that get too much sun and those where you'll lose heat. Because there is a range of strategies, even in retrofit, to improve on it. I'll come to. These days, many are double or triple glazed. Triple glazed is more common in Victoria and ACT. Double glazed is more common in the Sydney region. And of course, they all now have a U value and a solar heat gain coefficient value. And again, it's all jargon. It's meaningful to people in the industry, be it your builder, be it your designer, your architect. So talk to them about it. Solar heat gain coefficient looks at the glass alone and looks at how much heat goes through that glass, because different types of glass allow different heat to go through at different ratios. Whereas the U value, the conductive heat, that's a different measure. And the lower the U value, the better. And typically in warm climates, the lower the solar heat gain coefficient, the better. So one of the magic bits of mechanical material engineering in the last 20 years is what's called low E, low emissivity. That's what the E stands for. There are different ways of doing it, but essentially it's a transparent film, microcrystalline structure that can be put on the inside of clear glass. You don't see it, but it's there at doing a very effective job in deflecting UV heat coming in and allowing heat to go out. So it's a high-tech solution that is very common in any quality window manufacturer's catalog these days. So windows aren't windows anymore. You need to look very carefully, talk to experts, be it your window supplier, manufacturer, your builder, your architect, and talk about the different orientation, the different type of glass. So for example, one project actually for a North Shore resident who's got a weekender up in the mountains, he's got a lovely view, but bad orientation. So his northwestern windows and southwestern windows, where the view is, we're putting what's called toned glass. So the glass isn't crystal clear. It's like having sunglasses to minimize the heat gain. So on those orientation, we have looked specifically and changed the glass to give it the lowest solar heat gain we can get, because we couldn't use reflection just because of council rules and regulations, not wanting to blind people down in the valley below. There's many complexities in this kind of work. So your architect, designer, and your builder, and certainly the window manufacturer, will refer to WERS, Window Energy Rating Scheme. And they have tested and approved many different types, and you will be asked to make a selection And obviously price is associated with, is it double glazed, single glazed, do you have low E coating, is it toned? There is a range of price points according to that. So it's technical, but people in the know will be there to help you. So do look at that. I particularly get concerned about east and west if you get exposed to low sun, and bear in mind that when it's south, you get no sun coming in, but that's where you try and minimize your heat loss. Oh, house ventilation. Well, if you live in an old house, like I do, it's got ventilation in the walls, because in the days of kerosene lamps and the like, gas lamps, they had to get natural ventilation. So in my house, I took the vent off, I put some sprayed dark, thick insulation, put it back behind, and then put the vent back in place. So I kept the heritage look, but there's no longer the heat flow or heat loss coming and going. But we mentioned before, the roof and the ceiling is the first thing to do. The walls, if you can upgrade, do. If you're upgrading windows, well, certainly look at double glazing. And again, underfloor, they now make a series of different products where you can, if you can get access under a timber floor, you can fix it from below. But I can assure you it's a pretty horrible job. Don't try and do it yourself. I have, and I hated it. Okay, so mechanical fans, open windows and doors, and the more airtight the building is, and that's one of the things happening increasingly today, airtight buildings, we need to think more about our ventilation. We have to think more about how we are getting air movements in our building. Because I live in a cold climate, condensation is a fundamental. Think about it. Air contains water vapor at all times. We don't normally think about it, except when we had those really hot, muggy days a few weeks ago, we felt it. Because when you're at high humidity, part of natural weather events, our body feels it much more than a dry Mediterranean climate. So the water vapor, once it gets up to 50, 60, 70, 80%, it's muggy. Once it gets to 94, 95%, rain. So air does hold water vapor. The warm air holds more water vapor. And that's one of the reasons why we are starting climatically to have more dramatic rainfalls in Australia, in fact, around the world. Because as the climate has warmed, we are now very close to 1.5 degrees Celsius. Arguably, it's a tipping point worldwide, that it means that we, in some areas, El Nino, El Nina, we're getting long dries and then torrential rain wets. This is part of the future that we need to prepare for with a resilient design building or renovation. You do actually know about condensation because in your old house, in my old house, single glazing. Cold outside, perhaps warm, and you've got the bath running or the shower, or in the kitchen, you've got steam, humidity. So it's there as water vapor. It hits a cold surface, typically single glazing, and then turns from being vapor, a gas, into droplets of water. So you will probably have, many of you, the ring of water at the bottom of your windows, particularly in bathrooms, en-suites, kitchens. So this is appointable, fine, but where does it go inside a wall? Now, you're lucky. In a temperate area, it's not crucial. Where I live and work, it's very crucial. My own home had additions, badly done, but done to the textbooks of the time, 30 years ago now, and they just put reflective silver foil sarking behind the weatherboard. The weatherboard's well painted, no problem, you would think. But what was called the dew point is where the water vapor collects on the silver foil directly behind the unpainted timber. And in 10 years, that timber was ready to fall apart because outside beautifully painted, but the inside unpainted, the water was trapped and it rotted the timber from the inside out. Condensation occurs when humid air meets a cooler, impermeable surface. Glass, metal, silver reflective foil, that's a cooler surface. And so this is a point about building membranes and insulation. Wet insulation is no insulation. It's a liability. So again, in the last few years, we have got what's called intelligent membranes that will shed water, but allow water vapor to go through. So this is where the science, building science, has made big leaps, which we'll talk about very shortly when I'm talking about passive house, passive Hus, the German. Okay, here it is. You may have heard of it. It's the latest and the greatest for many people. Passive Hus is a German term, something they've developed over the last 25 or 30 years. And of course, it comes from Germany. Think about living in Germany. I've got family living there, I know it. You don't have a choice of orientation. You have more cloudy days than sunny days. It doesn't get that warm. It certainly gets quite cold. It can also get windy. It can also get smoggy, pollution. So if you're living in Germany or many other parts of the world, you don't have a comfortable temperate environment. You have to look at your building envelope and these key factors to protect you from the outside. So the whole system about passive house, as distinct from solar passive, which is natural system, this is a mechanical electrical system. And that is to allow you to cocoon yourself inside your building. Now, up here where I live, I wouldn't want to do it. It typically adds 15% or more to your building cost. But if you're living near a highway, if you're under the flight path of the airport or the future flight path, then it becomes highly relevant potentially. But remember, it's a particular technique. You need a passive house certified people to work on your design. So what's the difference? Okay, it's a design standard where it has a series of criteria about the insulation, the air tightness, the orientation, and the like. Particularly the air tightness. Most homes are leaky, to use the jargon. There's not sealants around the windows and doors. There's gaps maybe in the floorboards, particularly old houses. There could be gaps around light fittings up high. So your warmth in winter is going out, and in summer, the heat is sneaking in through all these different locations. So they particularly in the passive house look at the fabric, and they look at a optimized thermal envelope using computer modeling, which puts in your climate, which puts in all the variables to do with your house or your proposed house or your proposed house additions. And then it spits out what scientific conditions you must meet. It's not the same as a home energy rating under NatHERS, which has been around for 30 or more years. It's more specialized than that. And so we'll just say a bit more about it. Airtight construction. So here is a lightweight two-story construction. And no doubt there is several layers in the wall. There is a structural wall. There is presumably standard insulation. But on the outside of that, they will have an intelligent fabric, which is the requirement to be absolutely airtight, absolutely wrapping it. And there is tape to seal all the junctions. And around every window and door, again, there's a specialized, highly sticky tape to make sure there's no air loss, no air leak around windows and doors. At the end of that, they put in what they call their door test. When everything is finished, sealed, they, in the door, put in a big fan, a mechanical fan, and they draw air from the outside in and from the inside out and measure air changes per hour. And in doing that, If the reading is not good, and every old home, the reading will be appalling, but if you've done the passive house, it should be good. But if it's not what they expect, they then put some powder in the air and carefully look around to see where are the minute holes. It might just be literally a nail hole through the fabric, which is causing the air leak. So this is how they check and verify and have to prove to get passive house accreditation that they have done that. So that's about the fabric and the building structure. But then instead of opening windows and doors, that's what I do all the time. I have no problem with that. Some people, some situations, perhaps you don't want to. You want a more regulated internal air and cut out the noise of highways, etc. So they put in a mechanical ventilation with heat recovery. The point of that is each room will have, they'll draw air in, they put it through a mechanical electrical system that purifies the air and then sends it back. So it's minimizing the outside air coming in, it's just cleaning and purifying the inside air to make it healthy. So, yep, high performance windows and doors, well sealed, good glazing, and I've mentioned continuous insulation walls, floor and roof. It does cost more. It is very particular. And if you live in an equitable climate, as many of you do, you like to live outdoors, you're not fussed by pollution or road noise, okay? Open your doors and windows. I think myself, passive house is an optional extra for many of us. Thermal bridging is the other key point. And this is where the whole passive house movement has really helped prove about airflow and temperature variations through a wall. Think if you've got a metal cladding on your wall, you've then got metal studs, you're taking the outside temperature through the metal onto the inside. So this is a thermal bridge. So again, passive house has highlighted how you don't want to do that, and there is now increasingly specialized techniques to avoid it. So again, talk to your architect, talk to your designer, talk to your builder about all of that. Okay, I need to speed up. Retrofitting. Life cycle. We all have to do things over time on our houses, getting to know your building, how you use it, and particularly maintenance. Things don't last forever, and you need to be on top of it before the maintenance is forgotten and it goes too far and you're up to expensive replacement. So, improved building envelope, active design measures. You can obviously look for efficiency labels on your appliances, and particular heaters and hot water. And this is where the government, New South Wales government, has a scheme to replace old hot water system, energy inefficient ones, and at very minimal cost can give you a new, very energy efficient hot water system to replace at a subsidized cost. So look for that. There'll be more about it in these future webinars. But also, Renew has gone to Getting Off Gas Toolkit with webinars and technical information about how, again, you can head towards an all-electric home. If it's powered by renewable energy, again, you're minimizing your cost and you're minimizing the consequence for not just you and your neighbors, but consequences for the world. Landscaping, obviously important. Heat island effect is increasingly important, particularly Western Sydney, because of all the dark roofs. Shouldn't have dark roofs in hot climates. It should be light coloured roofs. But as you probably know, dark roofs, dark bitumen roads everywhere, houses very close together. And of course, it's heating up the whole environment. It's heating up a heat dome over many suburbs. So to minimize that, obviously plants, grass, landscaping, they provide shade, they cool the air, summer, warmer than winter. Western Sydney University research has shown it can be up to 10 degrees cooler in streets in Western Sydney lined by trees, good shade trees, compared to just a few blocks over when they get full sun exposure. So landscaping is not only great for comfort, great for livability, we can use it as a resilient strategy. But when it comes to gardens and bushfire, there is what's called fire-wise gardens, and some plants will obviously burn quickly and contribute to fire. Others will reluctantly ignite or not ignite at all. So again, you can look at fire-wise as a term, and you can get lots of information online. One of the interesting new things is the Resilient Building Council that comes from Queensland. They set up a few years ago, and they make the point that 9% of Australian homes are not currently resilient or climate adapted. So they've got a $3 or $4 million federal government grant, and they have produced a fantastic website on bushfire resilience. And in the next few months, they will be doing on energy efficiency resilience. So there's a reference to it on the bottom right of your screen, but also at the end where Renew will send you the contact. But of course, we're getting more extreme events. I'm sure you remember 2019-20 bushfires and the way for days and weeks you had awful smoke and 400 extra deaths in Sydney due to the smoke from the fire in the Blue Mountains and elsewhere. We're getting all of these climate issues happening, and they're happening more frequently because of the change in the temperature, creating maximum impact one by one, and all because of the way we're living. So energy efficiency, resilience, and saving money, being more comfortable is actually all works in together. Reduce inconvenience, save costs, reduce insurance. Insurance is becoming increasingly big wonders. Some areas can no longer get insurance. This is for floods in particular, but you can imagine that will be increasing as every disaster adds to the insurance burden, and the increase in cost is affecting more and more people. So if you have a resilient home, you can live through and recover from these kind of events. There's another one called bushfireresilient.org.au. So again, a good website, helpful, grassroots, explains how and why, the simple things you can do. And so it's useful following this in future days, weeks or months. Think about your home, think about what we've talked about here, but these are some of the contacts and the further information you can systematically consider the improvements to your home. I won't go into bushfire, but northern suburbs have typically sandstone country where you have the fingers of green, the gullies, the bushland, the national park, the river valleys, full of indigenous native vegetation, terrific. But if you're near them within 140 meters, you'll have a bushfire hazard. So I've got one project in Gladesville at the moment, next to Field of Mars Reserve. Didn't expect to get one at Gladesville, but there we go. Right above a steep gully, and it is foul flame zone where you have the worst of everything because it's close to the bushland. Exposure to flames, heat, embers, and wind. When it comes to flood, okay, think about the materials. Wet proofing, as they call it, dry proofing, raising the house up wherever possible to be above a flood level, or even just a surface flow of water, and then landscaping. So again, there is resilient design guides. And of course, the key point of it is at the lower level, at the level that water might rise to, make sure there are perhaps not gyprock, make sure there are finishes and materials and like furniture that can be lifted above the likely water level. But remember, what was likely in previous decades, think of the flood emergencies in the last few years, and people have had water meters higher in their house than ever have been conceived. So past history is not a recommendation when we need to look ahead. Okay, in 5 minutes, I've got to run through 5 projects of mine which deal with this. This is where I'm talking to you from. This is my eco-design studio in Katoomba above a southern gully and vegetation. I built it, what was it, year 2000. It won a national award for environmental considerations. I could not now do it with any outside exposed timber because of the fire risk. But inside you'll see I've got recycled timbers, all of which came from a demolition building. You'll see I've got a Velux double glazed roof window. Here it is facing north to the sun. More important than ever, because next door planted against my wishes, but he had council approval, Willoughby, which in Britain, for example, is regarded a noxious weed. It is incredibly vigorous growing. It's an evergreen and it grows to 40, 50, 60 meters, and it totally cuts off my morning sun. It should never have been permitted, but when I built this 25 years ago or 24 years ago, nothing was thought about it. I've got Solomit straw ceilings. Solomit, after they've taken the grain, they used to use the straw, so it's sound absorber and insulation, and cheap it was. It's got just galvanized wire and these 50mm thick panels I just stretch across. Inside, I've used non-toxic paints. Bear that in mind. There's now a whole range. 25 years ago, there was only one manufacturer imported from Germany and also a company from Byron Bay, but now most product lines will have a low or no toxicity. So this is where I work from. It won a National Timber Design Award for Environmental Commitment year 2000. Here's a project of a few years back where top right, if you look at the red roofs, the house is in the middle with a shed to the north, a garage to the north and a shed on the right-hand side, which is east. So we totally rebuilt because it was the 1920s falling apart, badly renovated house of 20 years ago, but the original house was 1920s. So explaining simply, we've got the simple rectangular northern addition facing due north. We filled in the veranda to the north. We also, because this is BAL 29 or BAL 40, all the materials facing the fire direction, the lowest part is non-combustible. So we changed the materials to be non-combustible, low down, yet kept the outside appearance from the street. So then we put in Velux roof windows into getting sunlight into back rooms. Normally they're dark. No, this is Katoomba. We need the sun more than you do in northern Sydney. We've got sun coming into back rooms because having southern windows, yes, there's a few small ones for ventilation, but you'll see that the master bedroom has a little Juliet balcony with shading. See how effective it is. And then we have a stainless steel mesh, and so that becomes the indoor-outdoor space because there's lots of mosquitoes here because there's still cows and sheep in the paddocks nearby. So the point on the bottom right is in the old building. It was so jerry-built, we had to re-roof it, change the structure. So we did something contemporary. We got in 10-inch by 10-inch, 250 by 250 recycled timber pole vertically, and we put in these flying struts. We put in a Velux roof window off to the right for north, and suddenly, instead of all these tiny little rooms jerry built, we had a big, beautiful open space. So it's a mixture of new and old that the clients love. This is a totally new house, although I was able to get it passed as an alteration and addition. Why? Because if you apply as an alteration and addition, the rules are less stringent than for a new home. I wasn't trying to get around for the rules, it just made life easier. Because this was the classic. This was in Lower Blue Mountains. It was the worst house, top right, on the best street. In fact, it was a cul-de-sac at the end of a street. The block faced due north, but look at the house top right. It was awful. It was chocolate-coloured, rumbled bricks inside and out. It was so overshadowed, it froze in winter. It had 4 different floor levels, even though it was officially single story. and a rectangular building. It was awful. But it was a double block of land, a small creek flowing diagonally across. And the problem with the original building was the garage was on the street end. You go down 6 or 7 meters on a too steep driveway. You then go up 6 or 7 meters on a too steep driveway, unless you've got a 4-wheel drive, to get to that house, to then get to more steps inside. But I told my client, this property is brilliant because we'll rebuild the garage, two-car garage and storage on the high side, and we'll put in a bridge, a steel bridge over the creek. So we're not affected by flood, no matter how high it is. And the original house, which was a rectangle, we demolished down to the concrete slab and then changed the floor level so it all became one, and then went off at 90 degrees. So where it came off on your left, it's actually 2-story. So in reality, here is the house, a 3-bedroom, lovely house with northern deck, a bit of shading. Looking down, they put in a swimming pool afterwards with non-combustible steps down to the lower level. But down below, we put in the grandparent, the granny flat, the secondary dwelling, so they could have family in that area, which opened straight onto the rocks and looking across this low flow creek. You might say, well, why? This is a northern view, obviously a drone looking down on it. You see how we've got high windows again, so you get sunlight into all the back rooms, massive photovoltaics. And here, because the neighbour looked straight at it from just over to the right, we used Core 10 rusty steel, and we sheltered from the late afternoon sun, but also the neighbour view. Anyway, it's a lovely house, and that would be Bal 29, Bal 40. Here's a heritage property. Top left is the 1920s house given heritage status because officially it had been in top end of the mountains. It had been an orchard. And of course, you wonder because there's just 4 scraggly trees left and a very ordinary house. Badly built in the 1920s, little rooms, so had no chance in the fire. The fire came through, again, Bal 40 or flame zone. And so how could we turn this house into something architecturally interesting for a Sydney sider who was moving from the North Shore up to the mountains? So this is what we did. Okay, the gate, instead of walking in the original front door, you'd walk through a sunroom. You walk diagonally across the living room, you go to a compact, ordinary 1940s kitchen, and there was 2 bedrooms to the south and a 1940s bathroom. Not very inspiring. My client was retiring up here, and he wanted 2-car garage, he wanted a workshop, he wanted further accommodation and more space. So we walk in behind the original building. There's the original building. And we do additions behind, but you walk in behind, and what you see here is literally a water tank. A water tank with a peaked roof, to which we put in a skylight top dead center. We put in slice in for a door. We slice in for the horizontal shade and protection as someone's waiting at the front door, little LED light strip. And that became, on plan, it's like the hinge, because on the left is the original rectangular house, and we moved that house out 17 degrees off to the right and made it 2-story, because that had the garage below, the living space, the kitchen, and everything else above. And it was all connected because when you walked in that front door in the middle of your photograph, you'd go down, 11 or 12 steps, you'd go up 6 or 7 steps, and you're right in the middle of the house. So again, all the living area is on one level, and the occasional guest, workshop, garage, everything down below. Top right is a photograph of what we did with the water tank. All we did is buy a standard water tank, put standard timber stud work around the circumference, put in bendy ply, as you can see, and made it just a lovely foyer before you go up or down. And the other point of note, the bottom right photograph, was, again, because it was heritage listed, we did one of the principles in heritage is if you make a change, you make it reversible. So the master bedroom had become or became had been the living room. It now became the master bedroom, and he wanted an ensuite and dressing area. So it had been a utilitarian house. It had sheds, packing sheds. So on the left of the entrance, just off the photograph, was a Corten box with full double glazing of recycled glass blocks that he can shower in the sun. This is an afternoon photograph. And again, for resilience and sustainability, we lifted it off the ground, because if we did slab on ground, the tree, the very ancient arbutus, would be killed off, would cut through the roots. So we pinned it on 4 points and deliberately built it just off the ground. So again, this is heritage. This is dealing with Bal 40. This is making a pretty ordinary 1920 house into something, well, quite remarkable. And the last home, I'll finish with this one, is a current project, again for a North Shore owner who is going to retire up here. So on the right is the site plan, and the contours show how steep it is to the northeast and the north. And the original house is this part through here. He wanted to add a generous sized studio. The carport he wanted to turn into a garage. And then he wanted redundancy, to use the jargon, because this is flame zone. And this is a house he's saying with a 50-year perspective. It has been in the family for 30 years as the original house, single story to the street, 2-story to the rear, to the northeast, which is the image there. And it had its problems. It had reached the end of its effective life, quite apart from the fact it would never withstand a fire. And it's flame zone, the worst of all. So cut long story short, we're putting in a 250,000 litre concrete water tank dug into the ground. Has to be dug in because we don't want landslip. It's on the top of a slope. 250,000 litres should be a lot. We are totally redoing the facade in that's over timber frame and then corrugated metal with all kinds of weak points that we had to get rid of. So now we are recoating it with zinc. We are putting in intelligent membranes. We are super insulating it. We are just exchanging the roof. That used to open once, doesn't anymore. So we're putting in a flame zone roof, which also has what it should have had in the first place, an eave that protects the sun for, in this case, 4 months of the year. It's a cold climate. We want more than you would in Sydney. And in those eaves, we are putting bushfire sprinklers, and we are putting in bushfire shutters and Bal 40 windows, which is shown here. These photographs taken just before Christmas, 6 weeks ago, 8 weeks ago. Here's a water tank dug in and about to get its concrete lid, which becomes a patio off the studio to the right. But this is now what's happened in the living area and then the bedrooms, in that the small windows are taken out. We're using part hammer Bal 40 windows, not flame zone, because there's the view. If you ignore that and ignore the scaffold, it's a lovely outlook. And he wanted to maximize the views from inside the house. So the regulations permit bigger windows if it's Bal 40, but we then had to have covered, you can't see it yet, flame zone stainless steel shutters. So this house has everything. It has passive built-in construction, which will meet flame zone. It has active systems of bringing shutters down and of turning on a very large water system on the roof, particularly on the glass and on the vegetation all around. So this is a large, expensive and very complex renovation and alterations and additions underway. So look, that's the presentation. Questions? These are resources. Don't try and rush it down now, you won't get there, but this is what Renew will send out to you if you've registered for this webinar. And certainly Renew has a whole series of really really good resources. There should have been another one. Oops, it got missed out. Don't worry about it. But for example, Renew magazine has special issues to do, or Sanctuary, to do with fire, special issues to do with flood. I've written a number about retrofit, and Ku-ring-gai Council, I did a webinar for them a few years ago, which are probably still on their website, about retrofitting in Ku-ring-gai for fire. So lots of information, too much to take in at one go, but hopefully this has given you the fundamentals. And now let's hear from Barbara, and I can get in there and answer for the next 20 minutes your questions. Thank you.
Thank you so much, Nigel. That was really interesting. I'm sure everyone is feeling quite inspired, and that probably opened up a lot of more questions as well about their projects of renovating or building. We've got a few questions in the chat, so I'll ask you. The one from Cameron is asking, how effective are the thermal barrier paints such as Therm or Dulux Acrytex for large brick walls that for various reasons have very limited scope for any external shading interventions?
I don't have the technical knowledge of those properties, thermal properties. I know the products. I suggest very little energy efficiency difference. A house project I've got underway now, we are deliberately, it was 2-story brick and faced the fire, and again, cold climate. So the upper level, the living level, we are putting vertical metal battens, 20mm vertical battens off the brickwork. We are then putting a vapor permeable barrier and then recoating with a BAL 40 or BAL flame zone coating. So we are increasing energy efficiency. We're increasing a double barrel bushfire resilience, because that's particularly it's flame zone once again, and helping with energy. Paints, or even those high build paints, will give hardly a measurable difference in the short term. Sorry.
Okay, thank you. That's unfortunate, but thank you for being honest. Another question is also about paint. Is it possible to paint over a 5-year-old's dark color bond roof?
Yes, definitely it's possible. I mean, the cost benefit is what I would wonder about. Yes, I mean, color bond is meant to last, 30 or 50 years or something of that nature. But like all these things, you've got to look very carefully at the preparation for paint. If you're going to do that and put in a light color, that would certainly reduce the impact on the insulation and your ceiling void, whatever's underneath the metal. It would certainly help. Obviously, the paler the color, the better. But just bear in mind, some councils actually have a prohibition on superlight colors because of its reflectivity. So you don't need permission. It's under exemption complying. You can repaint a roof or a wall, but it would be in your interest if people, for example, could get reflected light off your roof, to have a quick look at the council website, and don't go for silver necessarily. Go for a muted color that suits you, but certainly whichever paint system, read the manufacturer's requirements very carefully, because it totally depends upon a clean roof, full preparation before you put on the final coat. If you don't do that, it'll be done in 5 years. You'll have a bigger problem.
Okay, great to know. Thank you. Anyone else has any questions for Nigel about your own projects? Yeah, feel free to put them in the Q&A. We've got a few minutes left. I've got a couple more otherwise that I can ask you. And we got separately. About windows, window tinting can allow less heat into the house in summer, but it's the opposite in winter. So how do you balance that?
Well, this is the point of these clever films or transparent coatings. In a perfect world, it would be a coating on the glass. They're called soft E or soft low E. And typically that's only used in new double glazing because it's so soft. They put it on the outer pane of the double glazing, because otherwise, I mean, I had a client, a woman who had a nice big diamond ring, and as she vigorously scrubbed, she actually scratched the coating and made it awful. So, yes, there are companies that do specialized coatings that can reflect or absorb, but it's not as effective as either external shading through a physical barrier built to the building or foliage vegetation. So look at those first, and then otherwise go to any of these companies that have film coatings, which effectively you stick on the inside of the glass, and they've got quite a range. For, you know, east, west would be different from south, etc.
Okay, great. Thank you.
Sorry, even Bunnings have some of those kind of
Oh,
products, but there's more specialized companies again that you can find online.
yes. Okay. So don't rush into doing a DIY job. Look into it a bit more.
Absolutely.
Um, do you have any suggestions for the best energy efficient roof shape and material?
No.
It depends.
Yeah, exactly. There are so many variables. No. I mean, look, the key point is in the southern hemisphere, we want north. We want the majority, predominance of our windows facing north. And that is typically 15 to 20 degrees east of north is okay, but only 10 degrees west of true north is okay, because the afternoon sun, the heat builds through the afternoon, evening. So that's in particular where we need to shade and minimize our heat gain. Okay, my own daughter's house, Bathurst, she cops a lot of heat on her double skin brickwork and the gable end in effectively all in brickwork. So what I'm going to do is use some corrugated metal. It's going to have, before the corrugated metal goes on, 20 mil or more vertical battens, metal battens through to the brickwork, and then I'll screw in the corrugated metal horizontally, leaving it open at the bottom and open at the top. So the metal will get to 50 or 60 degrees, but the differential air pressure will mean that heat is not actually hitting the brickwork. It's causing an airflow, so the brickwork is shaded. So that's what I'm going to do, you know, for, I don't know, what's going to cost $1,000 or two, because it's going to take, you know, 5 or 8 years for trees. And it's a low cost way of absolutely stopping that many hours of afternoon sun heating up the brickwork. And in spite of the super insulation, it's going to get inside. So again, horses for courses. Yeah.
Yeah, that's fair enough. Yep. Great. Sounds like a good answer. And just a last one. So the homes in future, will they be designed with room dividers that can be used to make rooms more cozy rather than having these massive, huge spaces that are so hard to heat, etc.? Do you have an opinion on this?
Yes. In
Great.
that. Okay, obviously, traditional homes, older homes, had smaller rooms and they closed the door. And the point of that was when the heat source was limited, be it an open fireplace, and possibly inefficient, only 10% of the heat if you just got a standard brick fireplace. You only get 10% radiant heat. The other 90% is going up and out. Not good. Okay, so I'm in an old house. I put in a Jetmaster. So I can get about 60% effective heat. So, you know, I can still have my timber logs. I mean, not good for particulates, but we only use it on a few occasions. But it also convects hot air into the room. So that's about 60%. If you have gas or log heater with a glass door that encapsulates it, that obviously takes more particulate out, although of course, particulates is a big problem in Sydney, even more so in Western Sydney, the northern suburbs, because it hangs down. That's fog and smog. But it can be up to 80 to 90% energy efficient. But again, the environmental consequences in terms of respiratory illnesses is what means that you get demerit points if you have to apply to council for renovations and you go through BASIX, the sustainability index. If you want to use timber, coal, unlikely, but if you did, you are going to get demerit points. everything is heading towards using electrical power as well as super installation.
Yeah, okay, great. Thank you. I think that was it for all the questions we gotten. So if anyone has any burning questions, feel free to pop them now. Um, Otherwise, if you had anything else to add, Nigel, otherwise we can wrap up and people can go on and have their dinner if they haven't already.
Well, hopefully there's another question or two to come in. I mean, the biggest challenge now is alterations and additions. As one of those slides showed you, though, 90% of our existing 10.9 million houses Australia-wide, 90% are not resilient. I deliberately used that Resilience Building Council website earlier in the week to see how bushfire resistant my home is. And I know it's not, because it's old fabric, it's timber, it's got an overhanging tree, which for everyday life, my wife doesn't want to take out. So there's a limit to what we want to do. So I'm 1 star when it came to bushfire resilience. Don't tell anyone, because what it suggested, I'm not going to do. This is a point of risk assessment. I've put in a large water tank connected to another tank, and I put in a fire pump, a diesel fire pump, because they do not evaporate the fuel like a petrol one can, and you can't rely on electricity typically if there's a fire coming through. So I have a diesel pump. I have a regular fire hose reel, 36 meters long, in a good location that can cover my house, my work studio in the back of the garden, and I would be spraying the trees and the vegetation before the fire comes. And of course, I'd be wearing a hat. I would be wearing, wool around. I don't have balaclava, but balaclava is ideal. You minimize your exposure to burning embers and to heat, because that's what gets people. It only takes a few degrees of heat in a radiant heat, and you have to go inside. You have to shelter. Firefighters are wearing multi-layered clothing to protect them. You've seen it yellow. They are very effective, but once it gets past about barrel 12 and a half, barrel 19, then they have to retreat away from the fire. And this is where it used to be, houses protect people and people protect houses. But then 2019, 2020 fire, the mega fire, it's huge. We are in a different situation now compared to ever before. And fire, flood, storm, tempest is absolutely going to be more severe. So don't throw your hands up in horror. The Resilient Building Council will highlight things you could do. Some of these other webinars will tell you more everyday practical things. So yes, bit by bit, I have enhanced what we're doing, but no, I'm not about to put in metal windows on a traditional house. Yes, I'm taking off the timber deck. I'm replacing it with something which won't burn, and I'm putting a skirt around the base deliberately, because that's where the embers will collect and typically ignite a building. So there are some things you can do, some things you can't, but there's good advice out there. In fact, one of the I've done 2 or 3 articles for Sanctuary magazine exactly on this point of retrofit. So that's in the references at the end. So they're, short and sharp, but gives you priority about different houses, things to look at. Okay.
Yeah.
Hope that helps.
Thank you. Thank you so much. Very inspiring. We don't have any more questions, so I think we're, good to call it a night. Thank you so much, Nigel, for your presentation, your time, answering questions, showing the case studies. I think for me that was very inspiring because, it shows what can actually be achieved from non-resilient old school houses. So very good to see them in real life. As I mentioned, that was recorded tonight, so I'll send a link. It might take a few days to a week, and I will send a link to everyone registered. So don't worry if you haven't received anything, I will send it to you soon. And the QR code will pop up when we close the Zoom window. if you can take a few minutes and answer the survey, that would be great too. We really appreciate every piece of feedback that we get. And if you aren't registered for the other webinars, they are running monthly. So we've got 4 in total. There'll be one next month and for the next 3 months, basically. So we'll have sustainable building materials, how to select a sustainability team for your projects, and how to incorporate water and greening into your home or renovation. So I look forward to hearing those presenters as well. We'll send more information if you are registered closer to the date. Otherwise, feel free to jump on the website that you booked in from, where depending on which council you're from, and book in from there. Otherwise, I can send a link in my email as well. Anyway, thank you so much, everyone, for attending tonight and spending your evening with us. Thank you to Renew for helping us organize and partnering with us. And thanks again, Nigel. Have a good
Pleasure.
night, everyone.
Okay, bye
Bye.
everybody.
Bye.